I'm Mark Davies. I'm a Senior Geo-Environmental Engineer at the NHBC. We've obviously followed on from Neil's installation elements, and we're going to be now looking at the verification of gas protection systems on site. So this has obviously been mentioned before, but NF94 is now in place, and the old traffic light guidance was withdrawn on the 1st of July. And the NF94 provides an updated position on the ground gas situation. Historically, what that means for verification, historically, AMBER1 sites would have meant that we would have requested designs, but not necessarily requested verification, unlike the AMBER2 sites where design and verification were required. NF94 now aligns with the characterizations of BS 8485 and the verification proposals in Series C735, and therefore verification is required for all sites where gas precautions are required. So we're just going to go back to basics in terms of what the process of verification means. It's essentially the inspection and confirmation that the gas protection system has been installed as per the agreed designs to address the gas risks identified on site. Good guidance out there is Series C735. We've had it mentioned previously, but that's guidance for the designer, the installer, the verifier and regulator on the verification and integrity testing of gas protection systems. So in terms of verification requirements, it can be summarised into the following stages. Neil's been touching on this kind of siloed approach sometimes that we see. Not necessarily the verifier is going to be part of the verification strategy or the design. So it's important to familiarise yourself with those designs and the verification proposals. Quite often we see verification of gas precautions. We're still requesting gas designs and the verification strategy. So it's important that that's all in place before you start verifying any gas precautions. Essentially, you're looking at something. How do you know that it's been installed correctly as per the design? So it's important to familiarise yourself with all that information. In terms of the verification, we see a lot of focus on membranes, but it should be including all elements of that gas protection. So we're talking ventilation, membranes, service entries, and so on. And in terms of the reporting, following your site visits, integrity testing, whatever you've carried out on site, then that should be clear and concise in a summary in the report and submitted immediately, or as soon as possible. And then Neil again's touched on this, but once the verification has taken place and the information has been submitted, it's then up to site to then maintain that they are protecting those gas precautions on site, avoid weather damage and so on. So it's really important that even though the verification's happened, the job's not quite done yet. So verification frequency and timing. Series C735 has this diagram on the slide. It's all based on a risk-based approach, based on the gas risk, the design complexity, number of plots, and the installer competency. Generally, we see proposals for a frequency, which could be a ratio or percentage of plots that need verification. But timing is also the very important word here as well. We would expect verification to be carried out on the initial plots to ensure good workmanship, any potential snagging issues or issues during the installation process. It's not just a case of hitting that percentage straight away, do 20% of the plots and then don't see anything else for the rest of the build. It's important that we maintain that verification along the build phase just to ensure that consistency is there. The frequency also needs to reflect the actual specific house designs. You may have a relatively straightforward block and beam plot with a ventilated subfloor void, but you may also have rafted plots where you've got more complex stone venting layers or ventilation mats with reinforcement. So your frequency should really vary as well to those specific or more complex designs. You may want to look at those more complex designs more than more standard block and beam ventilated void. The verification strategy should clearly address which part is responsible for providing evidence for the verification. We'll obviously see strategies sometimes where ground workers are responsible for applying images of subfloor voids and the internal sleep events, or at a later point where it relates to the sealing of service entries. So the verification strategy should include all that information in terms of who's responsible. And in bold there, I've got it, but developers should retain records for all gas protection installation on site. Neil's just touched on this as well. Every single plot is going to be independently verified, so those plots in between, you should still have installer certification and photographs even from the developers as well. So you should be recording that information as a developer. So competency and accreditation, it applies in terms of risk assessment, design and installation, so it applies to verification as well. The verifier should not be the installer or have a direct link to the installer to avoid any conflicts of interest. If that situation is happening, we would expect third-party consultation to be required to review that verification process. There are accreditation schemes out there. Clare have the Gas Protection Verification Scheme, or you can get a level 3 diploma in verification of ground gas protection systems, which Neil as MVQ assessor is involved in that process. So there is accreditation out there. And Neil's touched on this again, keep talking to your site staff. There's a lot of people on site that won't have a lot of knowledge about ground gas precautions. So if we're dealing with site operatives, we can use toolbox talks, pre-start meetings. There's really good guidance, Syria C801, which has been mentioned previously as well. There's all good information there. Keep talking to site staff and make them understand why that membrane is there or why those air vents are doing there, and what if their work may potentially impact that. They can at least ask the right questions. In terms of verification, the procedures can comprise of the following methods. The first one and the most common one is the verification carried out by visual inspection by third-party verifiers. So this could be a series of photographs of the ventilation, the gas membrane and ceiling of service entries. You can also utilise various methods of integrity testing undertaken on a plot. So that could be something very basic like PIC testing, or you could use air lance testing. But just note that integrity testing is not a substitute for a well-designed and installed gas protection system. When used, integrity testing should be backed up with visual inspections. As mentioned before, installer sign-off sheets should also be provided for those plots that are not independently verified. You can include them also for the independently verified plots as well, but that information should also be provided within the verification reports. So moving on to visual inspections, we're going to look at the ventilation aspects. We commonly see large amounts of photographs of gas membranes in reports, but very minimal photographs of the ventilation, air vents and the sleeper vents. So we need to look at that ventilation because it provides that initial protection to a property prior to any ground gas permeating the gas membrane, and therefore should be evidenced and verified. In terms of the void itself, the verifier should be confirming the depth of the void below the plot to ensure the ventilation will be performed as designed. Alternative methods of ventilation that we see on site are stone venting layers or ventilation mats. It's important to look at those aspects as well in terms of the stone depth, the stone sizing, and make sure that they actually comply with the designs. Sometimes we see various aggregates mixed stone with fines in that clearly aren't going to work as well as a single size aggregate. The agreed designs will have the specified number and required spacing for external and internal air vents on a house type. Therefore, you should be verifying that sufficient provision of venting has been applied. We also should be looking at the air vents in terms of finished floor levels to ensure that they are going to be above ground level and actually achieve the airflow and cross flow required. The external air vents ensure the airflow below a property, and the internal sleeper vents ensure the cross flow, which is achieved to ensure the dilution of any potential hazardous ground gases. The spacing is also important as well. So a house type may require 6 air vents, and it's not the case of just counting 6 air vents. We need to ensure that those are spaced across the property. It's no good if those 6 air vents are all just along the rear elevation of the property. Amy touched on this earlier. Sometimes the floor construction can form part of the gas protection system, and therefore we should be verifying this also. Development sites may utilise the solid floor types as a gas barrier, so that's our kind of raft or our cast in situ slabs. And therefore, it's important to confirm the floor construction for that property and ensure it's installed as per the designs. If the design is specified for a reinforced slab or a raft, then we should be ensuring that it will perform as designed and not crack and create potential pathways for ground gas or potentially damage the gas membrane that's installed. So we also need to ensure that any reinforcement that's being placed is not causing damage to the gas membrane itself. So a photo here, we can see that the rebar has been floated above the gas membrane to avoid that issue. In terms of the membranes, the visual inspection of the membrane should comprise of the following elements. We should be looking at product labelling for the product. A lot of membranes have the logo and the product type already on them. So if that isn't present, then we should be looking at product labelling, packaging, that kind of thing. Just looking at the colour of the membrane doesn't confirm the product type. There's a lot of membranes that use black and blue and so on, so that doesn't confirm the actual product type. So we need more information than that. We should also be looking at the location of the membrane, and Amy's touched on this in terms of protecting those foil core membranes. If the membrane's placed above the insulation, ready for wet screen, it's got a foil core, then we will be asking questions why it's not below the insulation as per the designs. In terms of the membrane and the seals, we can carry out simple pick testing along the seals to identify any potential defects. Those should be marked up and recorded. We've got a good example here in the photo where a defect's been identified and marked up nice and clear in the photos. We're seeing more moisture damage issues in relation to timber frames and the gas membranes crossing cavity walls where it bridges moisture. If we are looking at gas precautions and they're installed horizontally, but the designs are showing that they should be stepped down, even though it's not essentially changing the gas protection, we should be flagging that up with the developer and the design to show that there is an alteration in the designs there and it's not installed as per the designs. If we are noticing damage or defects in the membrane, then it should be highlighted. Then that verification should also take place for the repairs of those. A lot of the time that may be a simple puncture that can be repaired on site with the installers, or if it's a bit more involved, that may need to involve a return visit to ensure that repair has been undertaken. In terms of membranes, we also have ancillary products. So these will be things like sealing tapes. We've seen various verifications where the incorrect product or tape has been used. We've seen the foil tape being utilised to seal two pieces of membrane together when clearly it's not sufficient. The other sort of ancillary products that we see are top hats, preformed cloaks or preformed corners. It's important to note those products are suitable and that they will achieve a suitable seal to the membrane. Service entries, again, are a potential weak spot. Amy touched on this earlier, that if you've got a raft foundation, a service entry is essentially a weak spot in that foundation or floor type. So it's important that that annulus that's left between the water main and the ducting is fully sealed, and we've got a photograph here where that's been carried out on site. So it's important to pick up those elements as well. So integrity testing can be utilised in the verification process to provide additional evidence that the gas precautions have been installed correctly and operating correctly. Integrity testing can comprise of varying methods of varying levels of complexity, but it's important that testing is undertaken in accordance with current guidance and carried out by operatives that have sufficient training experience. This obviously, I've discussed this earlier, but pick testing can use a blunt tool to basically assess welded seams, tape seams to identify any weak or unbonded seals. Air lance testing essentially does the same thing. It just uses high pressure jets of air to identify any potential weak spots in the membrane. Dielectric porosity tests, that's where a electric current is introduced below the gas membrane and a wand or a brush is then swept over the surface of the membrane, which acts as an insulator. So if we have any punctures or leaks within the membrane, then that will generate a current and then generate alarm. That way we can identify any damage. This is probably more suitable for testing larger flat areas like Neil had some good photos there, warehouse or large commercial properties. Not so great for some smaller details in corners and service entries. Trace gas testing, that can be carried out at a later point once the gas precautions are in, where a tracer gas is introduced into the subfloor void like CO2. And then all the external air vents are then sealed and a detector is used within the property to identify any potential leaks. Smoke tests work in a similar way, not so common in the UK, but it's a visual detection rather than a gas detector. So The only downside to this is if you've got relatively small leaks, it's going to be hard to spot those very small amounts of smoke. All these tests have strengths and weaknesses, but a combination of methods can be utilised. As with any verification, the tester should have the appropriate accreditation and knowledge to carry out the testing. So in terms of reporting, the ultimate aim of the report is to confirm that the gas precautions have been installed as per the gas designs and verified in accordance with the agreed strategy. If there is any variation, then this needs to be reviewed by the designer and confirm that the installation still addresses the gas risk on site. The designer approval should be in place for any variations that should be included in the reporting. The report should be clear that all elements have been inspected and comply with the designs. All corresponding photographs, installer certification, integrity testing, that should all be included as well. If damage is noted during the verification process, then that needs to be recorded. Sometimes we see that reported in the text, but we never see any photographs of that or the repairs being carried out. So it's important that's noted as well. And also those plots that don't require third-party verification, those also need to be included within the verification report. Sometimes we'll get developers where they want to clear 10 plots at a certain time, but we've only looked at 2 plots. We're not to know that the other plots in between have actually been completed. So that's where we need these installer certification photographs to confirm that. And we're going to touch on post-verification again. As soon as the verification's been completed, the report should be submitted to local authority, your warranty provider, to avoid any delays in the build programme if queries or issues are raised. We've spent good time and money on the installation and verification process, so it's important that post-installation protection is utilised. And I'm going to mention Series C801 again. It gives a good insight on how gas precaution can be protected on site. If post-installation damage does occur post-verification, then any remedial work should be designed and verified and reported. That's more of a responsibility for the developer and the site staff to highlight that. It's also important to note that remedial works may be carried out on a property that doesn't relate to gas precautions, but if they're replacing brickwork or screed and so on, it's important that people recognise that that may come into close proximity to our gas protection system. It just needs to be reviewed and verified. So just going to go through a series of watch points now at varying stages of verification and just raise some common issues that we see at the NHBC. So we'll start with ventilation. First photo, hopefully it's fairly obvious, but there's been this situation, there were some late changes in external works design, resulted in the air vents being buried and therefore impacting the ventilation and the crossflow below the property. This is quite a common occurrence where ventilation's not been reviewed as Part M designs, which relates to level access to properties. Photo 2, we've got the air vents above ground level, which is good, but we've now got an obstruction in front of it. This could be anything from utility boxes to vegetation. This is going to be a hard one for the verifier to identify, I appreciate that, but this is more for developers to identify on site themselves. And photo 3, this is kind of highlights the requirement for internal and external air vents. We've got our houses can be compartmentalised, so it's important that we have those internal air vents and external air vents to ensure a whole crossflow across the property. Here we've got 3 examples from a similar issue. These have all been exposed to weather. It just emphasises the importance of that post-installation protection of the membrane. It's also highlighting that when screed's placed down, majority of the time we've got membrane still exposed in those threshold areas, excuse me, and around the perimeter area. So it's important, even though the screed's been taking place, we still have got pieces of membrane that are exposed in high traffic areas like thresholds and around the perimeter. So it's important that we protect those also. These photos are going to just highlight the importance of experienced and qualified installers. These are examples of the tricky installation areas around air vents, thresholds and service entries, which can be avoided. Photo 1, we've just got a clear gap in the radon barrier here where there shouldn't be. And photo 2, again, a similar situation where 2 pieces of membrane, they've not actually been sealed together, just a piece of tape's been put on top, which doesn't achieve a required seal. And photo 3, hopefully I don't need to say much about this one, but this is just poor installation and some clear damage caused by follow-on trades as well. In terms of post-installation protection, we can utilise in photo 1 there we've got a protective membrane, or a fleece can be utilised to protect the gas membrane prior to any screed being poured. This is important anyway for any potential foil core membranes that are going to come into direct contact with wet screed or cement. Photo 2, an example just of perimeter areas that are being protected by boarding. The screed's gone down, but you clearly can still see areas of the membrane still exposed, so we need to protect all areas. And the third is an AI image I've used to just generate to highlight, and this is what Neil's been touching on. We do have this siloed approach, toolbox talks, pre-start meetings. These are all great just to identify to those site operatives that work in close proximity to gas precautions, their importance, and just highlight any sort of potential pinch points. In terms of reporting and timescales, once verification has been completed, the verification report should be submitted for review as soon as possible. Gas verification reports submitted 6 months, 12 months after completion may lead to delayed completions due to missing information or unsatisfactory verification. If the verification is undertaken and the designs or products have deviated from the original designs, then there must be justification or review of that product to ensure that it still addresses the gas risk on site. It also needs to be approved by the designer. We often receive reports where the installation's not gone in as per the designs, or the different products have been used and there's no discussion in terms of whether it still addresses the gas risk and if that's been approved by the designer. Verification reports should be clear and concise and have all the important details. It sounds like basic stuff, but plot ID, installer information, verifier, qualifications, dates. The report should contain clear photographs of the varying elements of the gas protection, not just volumes and volumes of photos of membranes. If damage and repairs are noted, then we should be seeing those photographs as well. Where plots have been independently verified, will require the evidence of their installation in between. So we have the independent verified plots, and it's those ones in between where we need those installer certifications. So it's important to include that in the report itself. And that's it from me. I think we're going to pass back to Steve now for a few questions and answers, hopefully. So thank you very much for listening.